Hello, and welcome to the Lux Research webinar on the final frontier, unlocking the potential of the commercial spaceflight industry. My name is Cord Eisenhagen, and I lead Lux Research's international business units across Europe, Middle East, Africa, and the Asia-Pacific region, and I'll be your host for today's webinar. Our speaker today is Anthony Schiavo, an analyst based out of our Singapore office. Anthony leads the advanced materials research team at Lux, where he regularly advises clients on strategic issues related to innovation, strategy, investments and partnerships, and technical issues relating to chemicals, materials, manufacturing, and sustainability. If during the course of Anthony's presentation you have any questions for him or about Lux Research, just type them into the Q&A box on the GoToMeeting platform, and at the end of today's webinar, we'll get to as many of your questions as possible. Now, before we get started, a few words about the challenges we are seeing in the chemicals and materials industries today, and how Lux Research helps companies like yours drive innovation and growth through these emerging technologies. Overall, there are a number of challenges in the chemicals and materials sector. First, we see a slowing of demand and rising competition beginning to erode margins as product commoditization encroaches on some of the more specialized application areas. Second, oftentimes we see the commercial reality of some of these new material technologies failing to live up to the market hype. And third, increasing pressure from investors to boost quarterly profits comes at the expense of corporate investments in longer-term innovation initiatives. So in the face of these industry dynamics, how do you find and foster new growth? Well, frankly, it's complicated. If you're the head of innovation, the head of strategy, product development, or corporate venture capital, many questions must be answered quickly so that you can more accurately define your strategic direction. For example, you must understand the market landscape, its key players, and you need an in-depth understanding of the technical specifications of some of these new early-stage technologies. And you must clearly identify the opportunities and the risks associated with them. And that's really where Lux Research comes in. Companies today need to supercharge their growth strategies with the right data and the right insights to get at the what, who, and when of technology innovation. And Lux Research provides expert curation of data-developed analytics, domain knowledge from our technology experts to answer that question in identification of key market trends and leading market indicators, and what you should be doing about them. Lux Research is the leading provider of tech-enabled research and advisory solutions, helping our clients drive growth through technology innovation. So as a demonstration of our approach, I want to pass things off to Anthony now, who will take us through a very interesting analysis on how you can use advancements coming from the space industry to fuel your overall chemicals and materials innovation efforts. Certainly, if you have questions about Lux Research or what we do, just ask them in that Q&A box or follow up with us directly after the presentation. So Anthony, I'll turn things over to you.
Thank you, Cord. Today, I want to talk about the final frontier, how you can use the potential of commercial spaceflight to really enable your materials innovation efforts. Now, you may be asking yourself, this is the materials analyst, why is he talking about space? Well, it's not just because we can now take selfies in space, but we're actually at the cusp of a major change in commercial spaceflight and a lot of new opportunities in space. At the same time, space has long been a creator of new innovations and new technologies for terrestrial industries. So today, I really want to just talk quickly about how things are changing in the overall spaceflight sector, highlight 3 key opportunities for material innovations that can really support commercial spaceflight, and then bring it back to Earth and talk about how you can start your own space tech innovation journey. So let's begin. We're really now entering an era of commercial spaceflight because new players, startup companies like Blue Origin, led by billionaire founder Jeff Bezos, and SpaceX, led by billionaire founder Elon Musk, have really dropped the cost of access to space. And this has created new business opportunities in space tourism, in communication, and it's really gotten people thinking about the long-term possibility for colonization. And it's not just that these companies have begun to emerge in space. Space is also getting renewed support from governments. In the United States, President Donald Trump has begun to push NASA towards returning humans to the moon, and even going further and planning deeper travel into the solar system and potentially to Mars. So we really see a growing opportunity for space-related commercial activity. Today, total space activity is worth around $330 billion, but by 2040, Bank of America Merrill Lynch thinks that that could grow to as high as $3 trillion. So there's really a huge opportunity for commercial activity. At the same time, spaceflight has always inspired technology innovation, whether that's fictional spaceflight, as Star Trek has inspired cell phones and tablets, or the very real inventions that NASA has brought to Earth, such as memory foam, radiant barrier, and dry lubricants. Those three products combined already have a $6 billion market size. And it's not just that, but NASA every year develops thousands of new technologies, has thousands of tech transfer agreements, and those technologies are typically quite well funded, both by governments as well as by private sources. So this space tech development translates into a lot of real world business opportunity. And so meeting the needs of this new era of commercial spaceflight will really enable you to create terrestrial business opportunities. So what are the needs of commercial spaceflight? Well, one of the biggest ones is cost reduction. Now that spaceflight is really a business proposition, it's critical that it be as low cost as possible. And although those startups I mentioned have brought the costs down, going into space is still a very expensive proposition. Secondly, communication. Communication is the backbone of a lot of the business opportunities in space, and it's a major challenge. As we get further and further away from Earth, the issues with communicating become bigger and bigger. And lastly, sustainability. And you might be thinking about sustainability in terms of the environment, but what I'm really talking about here is the ability to sustain life away from Earth for a long period of time, which will be critical if we want to set up long-term habitation on the moon or on Mars. So I talked a little bit just about how spaceflight is changing and how some of the commercial activities create new opportunities for innovation. But now I really want to bring those into specifically what the material technologies are. First though, I want to talk a little bit about the Lux Tech Signal. The Lux Tech Signal is one of our data analysis tools that Court mentioned, and it really combines an analysis of patents, academic papers, VC funding, government funding, and our own proprietary data to give an overall signal on the state of a technology's innovation activity. And what we see is that you can see changes over time, which really signal growing or shrinking interest. Inflection points point to important changes that are happening in the overall commercial activity. And the current value of that tech signal really indicates the overall maturity of an innovation. So we can use this as a tool to understand the state of different innovations. So I mentioned these three commercial spaceflight opportunities of cost reduction, communication, and sustainability. And I'm going to highlight one material technology that can address each one of these, although there are many potential opportunities for innovation here. And the first one I want to talk about is 3D printing. 3D printing is one of the most asked about technologies we get at Lux Research. If you're not familiar, it really refers to the manufacturing of objects layer by layer, adding material on top of more material, all based on a digital design file. And the key benefit of this technology is that it can really enable waste reduction and new designs, new shapes that aren't possible via conventional manufacturing. And what you can see in the tech signal is that this is really a very mature technology already. There's been a huge amount of activity since 2013 especially, and we really see this as almost fully commercialized and fully on the cusp of being very transformative. And in spaceflight, we really see an opportunity for metal 3D printing of engines. Engines rely on really expensive materials, high temperature alloys, that the waste reduction from 3D printing can really help reduce costs. At the same time, the novel designs enabled by 3D printing can really increase engine performance. What you see on the right is an engine that was actually 3D printed by SpaceX. And not only does this allow them to dramatically improve engine performance and save money on materials, but it also allows them to have control over the supply chain, really transforming their relationship with material suppliers and with their manufacturing partners. But this type of high temperature metal printing isn't just an opportunity for 3D printing for space, it's also an opportunity here on Earth. GE Aviation uses high temperature metals to 3D print large sections of their new engines, which allow them to consolidate a number of parts, save costs, and manufacture much more quickly. Similarly, Siemens is developing technologies to 3D print high temperature metals for power generation here on Earth. And again, that's allowing better optimization of their products and a better optimization of their designs. And so, second technology I want to highlight is metamaterials. Now, 3D printing was one of the most talked about technologies that we cover, but metamaterials you might not have heard of. These are materials with pattern structures that enable novel properties. And what's really exceptional about metamaterials is that you can create properties that are otherwise impossible by using very carefully patterned structures. Those could be physical patterns, could be patterns of conductive material and insulating material. There's really a huge range of different options here. Overall, this is a technology that you can see on the Lux Tech Signal has begun to pick up interest since 2003, but is still at a relatively immature state. Hasn't seen the type of overall explosive activity that we saw in 3D printing. Now, the opportunity with metamaterials is really in antennas, because metamaterials can create flat, compact, and solid state antennas. And if you look on the right, this is a picture from the Apollo 12 mission. And that large dish was necessary to send a focused beam, a focused signal back to the Earth. But that's really bulky, it's really large, it's heavy. They had to drag that up to the moon with them. But with metamaterials, it's actually possible to create a flat, compact antenna that fits more easily on a spacecraft. One company that's doing this is Pivotal Comware. They were just recently received an investment from the thermal companies, and the CEO of the thermal companies said this about them: "We see the Pivotal team as significant to our networks in the future, not just in their terrestrial applications, but also for their potential satellite communication applications as well." Similarly, Kymeta, one of the leading developers of metamaterial antennas, is working with SkyPerfect JSAT Corporation, a Japanese satellite communications provider, to deploy metamaterial antennas on their systems. So there's really opportunities here for metamaterials to meet the needs of space communication, but also terrestrial communication as we move into the era of 5G and IoT. And lastly, I want to talk about CO2 capture and conversion, which really we think of as the use of carbon dioxide either from a point source, like some sort of exhaust, or captured from the ambient atmosphere as a feedstock to create carbon compounds. Could be polymers, could be fuels, could be food. And really why this is critical is that it creates a new feedstock for these carbon compounds, which typically have to come from some sort of petroleum or natural gas feedstock. But this is really a sort of a new way of potentially creating these compounds. What you can see looking at the Lux Tech Signal is that this is a technology that's been slowly gaining interest since the 90s, but it's still at a relatively immature state, slightly higher than Metamaterials, but there's still a lot of work that needs to be done, a lot of challenges that need to be overcome. Now, why this is really critical for space? Well, on Earth, CO2 is only at about 0.041% concentration in the atmosphere. But on Mars, carbon dioxide is 95% of the atmosphere. And even though the atmosphere is much less dense, there's still 10x more available carbon dioxide in the atmosphere on Mars, meaning it's 10 times easier to do carbon capture. And NASA has recognized this. They already have a CO2 conversion challenge, looking first at making CO2 into glucose to feed astronauts, and in the longer term, turning CO2 into fuel. Because on Mars, there's really there's no petroleum, there's no petrochemicals. So if you want to have a long-term sustainable colony there, you really are going to need a source of carbon compounds, and CO2 is probably the best bet. But it's not just for production on Mars. Covestro now has a 10,000 ton per annum CO2 to polyols plant. And the thing is, the polyols they're producing result in higher performance polyurethanes than conventional technologies. So they're creating a product that's not only sustainable, using a novel type of feedstock, but is also higher performance as well. Okay. I spent a lot of time talking about space and some different technologies. Some are kind of in the near term, like 3D printing. Some are much longer term bets, like CO2. The question is, what can you actually do about all this? Well, I've shown you these tech signals for the three different technologies. And the thing about the tech signal is that it's not just a tool to understand the current state of a technology. It's something that you can use as a strategic framework and really assess where technologies are in terms of their maturity, but also what to do about them. So let's look at 3D printing. Well, with 3D printing, we can see that there's already been 3 key inflection points. This technology has undergone a lot of transformation already. And like I said, it's really already on the market today. So the strategy here is to use cutting-edge partnerships to enhance products that are already existing. And a great example of this is DMG Mori. They're a leading provider of metal 3D printing systems in Japan. And they have a partnership with Virgin Galactic. They're developing novel high-temperature alloys for space printing, specifically for engines. But the opportunity here isn't really for engine sales. Those high-temperature alloys can be translated into DMG Mori's other products and serve a wide range of applications in energy generation and aerospace. Secondly, metamaterials. We've seen that there's been a good amount of activity since 2003. But when you dig deeper into the data, what you see is that really it's academic activity fueling a lot of this growth. And overall, this technology is still at a relatively immature state. So the smart play here is still to focus on core IP and core competencies. That's what Northrop Grumman is doing with their partnership with Duke University. Duke is one of the original players in metamaterials, and this partnership focuses on simulation. That really helps address the complex design and manufacturing challenges around metamaterials, and it sets them up to utilize a wide range of different metamaterials, giving them access to a platform technology. And lastly, CO2 capture and conversion. We've seen that there's been steady growth over 2 decades, but there hasn't been the kind of inflection point that really denotes a technology breakthrough. There's still a lot of hard challenges to solve in this area. And so what we see smart players doing is aligning their core technological strengths to specific challenges. One example would be 3M, who has a partnership with Dioxide Materials. This partnership is really about leveraging 3M's membrane technology to use in dioxide materials process. In this way, 3M has a stake in carbon capture and conversion, but they aren't taking on the risk of trying to develop an overall carbon capture and conversion process themselves. So as we wrap up, I just want to leave you with 3 final thoughts. First is align your innovation efforts with the needs of spaceflight, because now that spaceflight is entering this commercial era, those needs such as cost and scalability are really well aligned with terrestrial businesses. Secondly, there's a lot of resources flowing into spaceflight innovation, whether it's from governments or from the private sector, and you can leverage those resources to fund long-term technology bets that you might not otherwise want to, or they might be too risky. And lastly, as you're planning your technology strategy, use data plus insight to make sure that you've got the right approach for the right technology. Thank you. And now I'm happy to open it up for any questions.
Thank you very much, Anthony. That was a tremendous presentation. I hadn't really considered space flight's impact on the chemicals and materials industry. It was really quite informative. Let's move to the Q&A section now. As a reminder, if you do have any questions, please type them into the Q&A box on the GoToMeeting webinar platform, and we will address as many as we can in the time we have left here. Anthony, there's a number of questions coming in. Let me just pick a few of these to start. The first question is referencing 3D printing. The question is, can metal 3D printing scale up and meet the needs of manufacturing sectors? Isn't it mostly for prototyping now?
Yeah, that's a great question. And certainly historically, we've seen that metal 3D printing and 3D printing as a whole has really been a prototyping technology. But today, we're really seeing the growth in the manufacturing sector. And a lot of the technology development is focused on enabling scale up and enabling higher value production. For example, there's a lot of groups looking at metal wire 3D printing, which allows better throughput and larger components.
Thank you. Let's move to the second question, one regarding the government. You were mentioning government support for spaceflight. What governments, other than the US, are actively looking at this particular area?
Yeah, one I'd highlight is Japan. The Japanese government recently announced a $1 billion fund for spaceflight innovation activity and space commercialization. Also, JAXA has been very active, and the commercial spaceflight sector in Japan has been very active. JAXA, that's the Japanese Space Exploration Agency, just recently landed a probe on an asteroid. I'd also highlight a lot of space activity in China and India as well.
Thank you. Let's take a couple more questions here. I'll paraphrase this next one. Can you explain metamaterials in more detail? Specifically, what is the manufacturing process or how are they produced?
Yeah, so metamaterials really rely on the differences between 2 different types of materials. So that could be a difference in properties between a electrically conductive material and an electrical insulator. And they rely on having a pattern that's in the same wavelength size scale as the wave that you're trying to interact with. So if you're trying to interact with a radio frequency wave, you'd need a pattern that's centimeters to larger, so of conductive material. And you can actually create that with fairly standard electrical or electronics manufacturing techniques like printable electronics. As you get into different types of waves, it can become more or less challenging, but a lot of the conventional techniques are being now repurposed for metamaterials.
So let's take one last question here. Let's tackle a more strategic issue. What are some of the other partnership opportunities you see out there? Where should people be looking for partnerships today?
Yeah, I think you really got to think about technology by technology where you want to be. So in 3D printing, I would highlight a company, Relativity Space. That's a company that's developing a large-scale metal printer using a wire feedstock, high temperature alloys, and they're specifically targeting space, not just production of engines, but actually production of whole fuselage sections and larger sections. As a technology that's great for spaceflight, but I think it also has a lot of potential opportunities in large-scale metal manufacturing here on Earth as well. And then, in something like CO2, I would look to longer-term bets. So as a company like Sizigi Plasmonics is developing a whole new catalytic system, works at room temperature, doesn't require a lot of energy input. It's a moonshot type of technology, still at a very early stage. But when you're looking to tackle these large challenges, these significant challenges, I think you can look to some of these earlier stage companies and technologies to really prepare yourself for the future.
Great, that's fantastic, Anthony. Thanks again for a wonderful presentation and for answering some of the participant questions today. We're just at the end of our time today, and while we weren't able to get to all of the questions coming in, if you did submit one or if you still want to, just email us directly and we'll get back to you as soon as we can for follow-up. We will be sending out the presentation and recording to everyone who attended today. You can also follow us on LinkedIn, on Twitter, and our blog for ongoing information and analyst insights on this topic, as well as a whole host of other innovation and emerging technology topics. On behalf of Lux Research, I thank you again for your attention today. Thanks again to our presenter, Anthony Schiavo, and I wish all of you a great day ahead. Thank you very much. Goodbye.